By the way, when I say that that's a joke, that's using the term lightly, a joke. Right? Let's see, let's stretch. Okay, cool. Determine if the EVT applies, and if it does, find the extrema. Extrema means what? X values or Y values? Y values. Max or min? Both. Local or global? Global. Sweet. And we know they can occur at either endpoints or critical values. First of all, does the EVT apply? Well, I got a closed interval. That's pretty sweet. Is this function continuous on that interval? I have a sine function and a cosine function, both of which are continuous on their own everywhere, and I'm adding them together. Yeah. So it is. So we'll just say F is continuous. Where? In France? No. On the interval from 0 to 3 pi halves. Comma, so the EVT applies. And so now we know we're going to be guaranteed not just a max, but both a max and a min. All right, we already got team endpoint, right? We don't need to declare team endpoint. When your endpoint x values show up in your calculations for the y values, f of 0, f of 3 pi halves, that's declaring them as candidates. So we need the derivative here. So f prime of x. Two terms. Yay, two terms. What's the derivative? 2 sine of x. 2 cosine of x, right? Pretty reflexive now to do that one. Pretty easy. And the derivative of negative cosine of 2x should end up being positive sine of 2x times the chain rule 2, which I wrote in the front, anticipating that it would be there. All right, now very quickly before we proceed with setting it equal to 0, is this ever undefined? No, because it's also the sum of 2 sine and cosine functions, which are continuous everywhere. So it's never DNE. So if I'm only going to use this once, I can go ahead and set it equal to 0. 0, right there. Set it equal to 0. 0 means 0 right there. Oh boy. Okay, so now I have two terms that's equal to 0. I'm looking for a common factor. I spy a 2. I do too. But notice we don't have a trig function that's common. In fact, the angles are different. And if we have a hope of factoring out a trig function, we need to make the angles the same. So we can either try to build up the x from the cosine into a 2x. No, thank you. Or break down the 2x that's there and turn it into a 1x. If only there were a way. Is there a way? Yeah, it's called the double angle identity for sine. So let's go ahead and do that. 2 cosine of x plus 2. I'll use purple for the change. Sine of 2x, we all know is? There it is. There it is. Okay, now you can call that a 4 right away because I know you can do that in your head. But now I have my angles the same. And now I not only have a 2 that's common, I have a cosine of 1x that's common. Oh, that's sweet. So I'll factor out a 2 cosine of x from both terms. I should still have 2 terms. I'm left with the 1 in the first term. And taking one of those 2's away and the cosine, I'm left with 2 sine of x equals to 0. Now I can set each of those equal to 0. And I'll go ahead and show that just because there's a little bit more work to do and I don't want to try and do too much in my head. But from here, maybe you can. I'm going to go ahead and isolate my trig functions first and then go to the unit circle. So that one becomes negative 1/2. And luckily without a calculator, if you're doing it right, these should come out to be unit circle ratios. So now I just need to think of where cosine and sine are 0 and negative 1/2. Well, there's infinitely many angles, right? So let's come back up here. We want all of the angles between 0 and 3 pi halves. So we're not talking about the inverse sine and inverse cosine functions now. We want all the solutions between 0 and 3 pi halves. That's basically 3/4 of the way around. Quadrants 1, 2, and 3. Okay, let's go for it. Starting with the first one. Cosine is equal to 0 where? Pi halves and 3 pi halves. 3 pi halves is the right endpoint of the interval, so he just got in there. Critical value and an endpoint. Nice. Sine is equal to negative 1/2 in quadrants 3 and 4. So the reference angle is pi 6, so the one in quadrant 3 would be 7 pi 6, and the other one's 11 pi 6, but we don't want 11 pi 6, right? It is a critical value, but it's not in the interval, so 11 pi 6 is out. So of the 3 critical values, only 2 of them are new to the game because 3 pi halves was already in. So we really have 4 values now that we need to evaluate it at. So what I'm going to do is move all this stuff over, kind of clear the stage, essentially. Now that we have our candidates, or contestants, I should say. And we're going to evaluate it in no particular order. F of 0, F of, we might as well do it from left to right, pi halves. Not that it matters. And then 3 pi halves. Well, 7 pi 6 would come next. And then F of 3 pi halves. And then, of course, it's everyone's favorite time, other than extreme game show time. That's quickly becoming one of my favorites. It's unit circle time, and that could be another game show, right? Units, or a Saturday Night Live skit, at least. Game show skit. All right, help me out. F of 0, we plug it in, and 2 sine of 0. Sine of 0 is 0, so this first term becomes 0. And then I get cosine of 0 is 1. So 0 minus 1 is negative 1. So it's not going to be difficult. It's got to be very mindful. And if you need to write stuff down, that's fine. Pi halves. Sine of pi halves is 1 times 2 is 2. I'll write that down. And now when I plug a pi halves in over here, I multiply by 2 to get pi. So cosine of pi is negative 1. So minus a negative 1 actually becomes plus 1, and we get 3. Next one, 7 pi 6. Sine of 7 pi 6. Negative 1/2 times 2 is negative 1. Cosine of, this one's funky. 2 times 7 pi 6 is 14 pi 6 or 7 pi thirds. So I have cosine of 7 pi thirds. Well, that's bigger than 1 rotation. So remember, coterminal angles have the same trig ratio. So if I subtract the full rotation, which is 2 pi, or 6 pi thirds, it should be equal to cosine of what's left over? Pi thirds. Yeah, they're coterminal. And cosine of pi thirds is positive 1/2. Wowza. Now be careful. It's minus that number, so I get minus 1/2, and it becomes minus 1.5 or 3/2, whichever you prefer. Kind of fun. And then finally, 3 pi halves, I plug it in. Sine of 3 pi halves is negative 1 times 2 is negative 2. And once again, I'm going to have to get a coterminal angle here because when I multiply 2 times 3 pi halves, I get 3 pi. But 3 pi is coterminal with what? Here's 1 pi, 2 pi, 3 pi is coterminal with pi. So it's the same as cosine of pi, which is negative 1. So minus negative 1 is plus 1, and we get negative 1. Whew. That was kind of fun. Well, all that hard work is going to pay off because now we just have to spot which one of those numbers is the biggest and which is the smallest, and we know we're going to have one of each. So F has a ... suspense, right? Max, let's do the max first, of what? 3, yeah, at x equals pi halves. And the minimum value is negative 3/2, yeah, at x equals 7 pi 6. So both of those were on the interior, weren't they? Both of them were at critical values. The endpoints were both negative 1, and if that had been the minimum value, then of course we would just say it occurs at 2 different places. So here's what the graph looks like. I'll go ahead and show you because it's still in there from last period. You type it in there. What mode should you be in if you're typing it into Y1? Well, I type mine into Y2. You need to be in radian mode, right? You type in the original function. Here's what I mean about the window. You need to go from 0 to 3 pi halves. But here's the thing. 3 pi halves is an irrational number, right? Because pi is. If you try to evaluate it sometimes at an endpoint on your screen, it might, because it truncates, it might not have it. So it was 4.7 something, and I changed it to 4.8. But anyway, when you hit graph, here's what it looks like. And you can verify it. Hit the trace button, type in a 0, you get -1, just like we thought. Type in a pi halves, and you should get what? 3. What's nice about doing it from the graphing screen is you got a nice visual. You got a little blinking icon, whatever it is. It shows you where you're at. The next one, 7 pi 6, that was our min. So you can actually type it in just to verify. At some point, you're not going to need to verify, right, because you know how awesome you are. -1.5, that looks good. And then here's the one where you'd have to kind of change the upper bound. 3 pi halves. When you hit enter, it does give you -1. But notice it's 4.712389. When I set my window at my X max at 3 pi halves, it wouldn't evaluate it there because pi is irrational and it chopped it off. So sometimes you have to adjust it. All right, that's it. We will save the example 10 and 11, the piecewise functions and functions that don't have closed intervals that are or continuous. We'll save those for tomorrow. So we'll finish the notes tomorrow. That's Thursday. The worksheet will be due on Monday, and the test will be due on Friday. And we will roll right into 3.2 tomorrow because we don't have to take a break for test review, right? Okay.